Hi, my name is Roteja. I am from EC department. My roll number is 24BQ18043. Today my seminar topic is ergodic process and its properties. Introduction to ergodic process. An ergodic process is a type of stochastic process in which time average are equal to a simple average. In simple terms, observing one sample of the process over a long time gives the some results as observing many simple samples at one instant. Meaning of ergodicity. Ergodicity means that statistical properties of a process can be determined from single realization over time. It ensures that the process is time invariant in its statistical behavior. Classification of random process. Random process are generally classified into three types. First, sta- first one stationary and non-stationary. Second one ergodic and non-ergodic process. Third one ergodicity is a special property often applied to stationary process. Sta- First one stationary was process ergodic process. A stationary process has statistical parameters, mean variance autocorrelation, constant over time. An ergodic process is a stationary process where time average equal ensemble average. Mathematical representation. Let x of t be a random process. The process is ergodic if mean limit t tends to infinity to t by 1 by t integration of x of x of t into dt is equal to e of x of t. Autocorrelation. Limit t tends to infinity 1 by t integration of x of t plus tau dt is equal to e of x of t plus tau. Types of ergodic process. First one, mean ergodic process. Time average of mean equals assemble mean. Autocorrelation ergodic process. Time average of autocorrelation equals assemble average. Cross correlation ergodic process. Time average of cross correlation equals to assemble average. Yep. Mean ergodicity. A process x of t is a mean ergodic if the time average mean equals the assemble mean. Formula limit t tends to infinity 1 by t integration of x of t into dt equal to x of t, e of x of t. This means observing one equal over time gives the same mean of multiple signals. Autocorrelation ergodicity. A process is a autocorrelation algorithm limit t tends to infinity 1 by t integration of x of t into x of t plus tau into dt equal to a of x of t plus tau. This ensures the time correlation matches the ensemble correlation. Cross correlation ergodicity. A process is a cross correlation ergodic if limit t tends to infinity 1 by t integration of x of t plus tau dt is into dt is equal to e of x of t into y of t plus tau. This ensures the time correlation matches the ensemble correlation. Importance of ergodic process. Ergodic process importance simplifies analysis of random signals. It helps in signal processing and communications. It is used in to model noise and other statistic behaviors. Fourth one, it uses the need for multiple realizations. Ergodic theorem. The ergodic theorem states that for ergodic process, time averages converge to ense- ensemble averages. This is a foundational concept in probability and statistic process. This is also used in ergodic probability and statistic processes. Examples of ergodic process: white noise process are zero mean or constant power. Certain Mar- Markov process, random binary random binary signals which equal to probability. Fourth one, stationary Gaussian process. These are examples of ergodic process. These are also binary signals are equals to probability. Stationary Gaussian process are used in the ergodic process. Non-ergodic processes. In non-ergodic processes, time average and assemble average are equals to are not equal, and time average and assemble average are not equal. Example: random process with the time varying mean or variance is the example of non-ergodic process. Such process cannot be analyzed using a single realization. Non-ergodic process. These topics are non-ergodic processes. Applications of ergodic process. Ergodic process are applied in communication systems or noise modeling system. Second one, control systems. These are also used in control systems and signal processing. In signal processing also, ergodic processes are used. Slide. Statistical mechanics. The ergodic processes are used in statistical mechanics, reliability, and quantizing theorem. Conclusion: ergodic process simplify the study of random phenomenon by allowing time average to represent ensemble behavior. They are crucial in analyzing stationary random processing in engineering science. Conclusion is ergodic process simplifies the study of random phenomena by allowing time average to represent ensemble behavior. They are circular in analyzing stationary random process in engineering and science. Thank you for this given opportunity. See today my seminar topic.